self-inductance, also we can say self-induction. First we'll see definition, what it says. It says the phenomena of production of induced EMF induced in a coil due to change in current in the same coil. That means when the current in a same coil changes, EMF gets induced. If you remember Faraday losses, whenever magnetic flux linked with the coil changes, EMF gets induced, and Lenz's law gives the direction of induced EMF. Suppose this is a coil of number of turns, we can say. This coil is connected to a source of battery, EMF, and this has a plug key. When the key is closed or when key is open, the current through the coil changes. That means current may increase or may decrease depending upon we are closing the key or opening the key. Now suppose in this case, if key pressed, that means circuit is closed. At that instant when the circuit is closed, current through this coil increases. As current through this coil increases, magnetic field produced in this coil, that means magnetic flux linked with this coil changes. As the magnetic flux linked with this coil changes, EMF gets induced, and direction of induced EMF is given by Lenz's law, that is to oppose the cause which produces it. So when key is closed, as current increases, magnetic flux linked with the coil changes and EMF gets induced. In this case, the direction of induced current is opposite to the direction of current. This EMF induced also we called as a back EMF. Now when key is released, that means circuit is open. When circuit is open, at that instant current decreases. As current decreases, again current changes. That means magnetic field gets produced, that is magnetic flux changes, and whenever there is a change in magnetic flux linked with the coil, EMF gets induced. Now in this case, the induced EMF has a direction same as that of direction of current, that is as per the Lenz's law. Now that means whenever current in coil changes, EMF gets induced in a same coil. When current in a coil changes, EMF gets induced in a same coil. That means EMF induced in coil due to change in current in the same coil. This phenomena we called as a self-induction. Now flux which is produced here is directly proportional to current, क्योंकि जितना current ज़्यादा रहेगा उतना flux ज़्यादा change होगा, जितना current कम रहेगा उतना flux कम change होगा. So flux is directly proportional to I. If I remove the proportionality sign, you can write constant, that is L. So L is constant of proportionality called as coefficient of self-induction or self-inductance. Or we can say L is equals to flux, that is phi upon I. If you have number of turns, then you simply multiply by N. So N phi upon I is equals to L. So number of turns, magnetic flux upon current is equals to self-inductance. So even we can define self-inductance. Self-inductance of a circuit is a ratio. It is a ratio of magnetic flux. This is magnetic flux. So magnetic flux linked with the circuit to the current flowing in it. So magnetic flux linked with the circuit to the current flowing in it. Now if you go for the unit, then according to Faraday's law, E is equals to minus d pi by dt. What is flux? Flux is equals to, we have L into I. We'll put this value of flux in that equation. So flux is equals to Li. L is a constant of proportionality that we took outside the derivative. So L di by dt is equal to E. If I take only magnitude, we are taking only magnitude, the sign nahi lenge. E is equals to L di by dt, or L is equals to E upon di by dt. Unit of EMF is volt, unit of current is ampere, unit of time is second. अगर मैं सेकेंड को ऊपर लाता हूँ तो volt second upon ampere, volt upon ampere, that is V upon I, that is a unit of resistance. So volt upon ampere we can say ohm. So ohm second or we can say Henry. So unit of self-inductance or coefficient of self-induction we called as a Henry. Next part. Now inductance of solenoid. Suppose this has a solenoid, long air cooled solenoid of length L, diameter D. When current passes through this solenoid, magnetic field produced within a solenoid is given by formula B is equal to mu 0 Ni, where N is number of turns per unit length. Or we can say capital N is equals to small n into L. And magnetic flux, because as current passes through the coil, magnetic flux linked with the coil also changes. Magnetic flux is equals to your formula B into A, B mu 0 Ni, A as it is. Formula for self-inductance, as we just discussed, self-inductance ratio of flux to the current flowing through it. If your number of turns multiplied by N, flux is equals to, we are putting the value of flux from here, that is mu 0 Ni, flux is equals to this. I get cancel, so mu 0 Na, capital N is equals to N into small l, N into N square, L as it is, mu 0 as it is. Area, if it is circular, then pi r square. R is a radius, that is diameter upon 2. So R square is D square upon 4. So we can say L is equals to N square L mu 0 pi D square upon 4. That means self-inductance is directly proportional to N square, and we can say L is directly proportional to D square when remaining quantities are constant. Next part, inductance in series and parallel, more or less same as the resistance. When inductance are connected in series, effective series combination is equal to L1 plus L2 plus and so on. In parallel combination, 1 upon L is equals to 1 upon L1 plus 1 upon L2 plus 1 upon L3 and so on. Energy stored in magnetic field. Just we discussed, when the key is closed, at that instant current in the circuit increases. Because of the change in the current, magnetic flux linked with the coil changes, and whenever there is a change in magnetic flux linked with the coil, EMF gets induced, and direction of induced EMF is given by Lenz's law. When current increases, direction of EMF induced and current both are in opposite direction according to Lenz's law. So when the circuit is closed, the current in the circuit increases, so does the magnetic flux linked with the coil. The formula for EMF, we have only magnitude, E is equals to L di upon dt. This derivation you can do by with the help of work done, or you can do with the help of power. We are doing with respect to power. Power consumed in a circuit, P is equals to E into I. EMF, we have L di upon dt, I as it is. Now total energy stored in a magnetic field when current increases from 0 to say I in time interval 0 to t. But when you are closing the key, current increases from say 0 to I in time 0 to t. So total energy stored will get by integration, total energy of integration from in time 0 to t, p dt, integration of power with respect to time. But power is equals to what? Power is equals to your L di dt into I. So this power is equals to L di upon dt into I. This dt as it is. This dt get cancel. So remaining part L I di I को मैंने आगे लिखा L I di integration from 0 to I, that is current increases from say 0 to maximum I. L is constant of proportionality that we took outside, that is self-inductance. 0 to I di, integration of this I is I square upon 2, or we can say half L I square. That means energy is equals to half L I square. Now mutual inductance M. Let's say first definition. It is a phenomenon of production of induced EMF in one coil. एक coil में EMF induced होगा due to change in current in the neighboring coil. So whenever there is a change in current in one coil, EMF get induced in other coil. That we called as a mutual inductance. Diagram you can draw this way or you can draw this way also. This is suppose a primary coil, number of turns, which is connected to source of battery E and the plug key. A secondary coil, this we are connecting to galvanometer. This is also same diagram. This is primary coil which is connected to battery, plug key, and secondary coil we are connecting to galvanometer. Now when key is closed, at that instant current through the coil increases. When current changes, the magnetic flux, magnetic field or magnetic flux linked with this coil changes. As this magnetic flux linked with other coil also changes because we are placing near to each other. So as magnetic flux linked with this coil changes, the magnetic flux linked with this coil also changes. And whenever there is a change in magnetic flux linked with this coil, there is a current induced. That means galvanometer shows the deflection. I repeat, whenever current switch is closed, at that instant current changes. That means current increases. As current changes, magnetic flux linked with this coil changes. As magnetic flux linked with this coil changes, the magnetic flux linked with this coil also changes because we are placing near to each other. As magnetic flux linked with this coil changes, EMF gets induced in this coil. That means change in current in one coil, EMF induced in neighboring coil. This phenomena we called as a mutual inductance. So induced EMF in one coil due to change in current in neighboring coil we called as mutual inductance. Vice versa also possible. That means to primary coil you can connect the galvanometer and this battery and plug you can connect to this way. Same thing will happen. There is a change in current in this coil, the magnet EMF induced in this coil. So you can say phenomena production induced EMF one coil. It may be this coil or may be this coil due to change in current in the neighboring coil. Flux induced in secondary coil and current change in प्राइमरी कॉइल. करंट किस में चेंज कर रहे हैं हम यहाँ पे? प्राइमरी कॉइल में. और फ्लक्स किसका ले रहे हैं हम? इंड्यूस्ड इन नियर बाय अनदर कॉइल. सो फ्लक्स इंड्यूस्ड इन सेकेंडरी कॉइल, चेंज इन करंट इन प्राइमरी कॉइल. सो एज पर माय डेफिनेशन, करंट इन वन कॉइल, EMF induced in other coil. If I remove proportionality sign, I can write mutual inductance M, where M is coefficient of mutual inductance, mutual induction or mutual inductance of coil. According to Faraday's law, ES is equals to, that is EMF induced in secondary coil due to change in flux in secondary coil. क्योंकि यहाँ पे जैसे flux change होगा, EMF क्या होगा यहाँ पे? Induced होगा. So EMF induced in secondary coil, change in magnetic flux. Flux is equals to your MIP. M is constant of proportionality. We'll write this way. This dIP upon dt. So EMF induced in one coil, change in current in other coil. If I take magnitude, then we can say ES minus sign हटा देंगे, M di by dt. To get the unit, M is equals to ES upon di dt. As we did in self-induction, EMF unit is volt. This is ampere. This is second. Second ऊपर आएगा, old second ampere. Old per ampere is ohm. So ohm second. Again we called unit of mutual inductance is Henry. You can write mathematically mutual inductance is equal to flux in secondary upon current in primary. Remember students, here we took primary and secondary. You can take 1 and 2 also. You can name coil 1, you can name coil 2 also. Fine. If a number of turns, then you have to multiply here by n. Remember this formula will require for next derivation. Next, coefficient of coupling between two circuits. Coefficient of coupling indicated by symbol K. First we'll see definition. coefficient of coupling is the fraction of magnetic flux produced by the current in one coil that is linked with other coil. Means कितना पोर्शन ऑफ मैग्नेटिक फ्लक्स जो एक कॉइल में प्रोड्यूस हुआ वो दूसरे कॉइल के साथ लिंक है. हाउ मच इज द फ्रैक्शन ऑफ मैग्नेटिक फ्लक्स प्रोड्यूस इन वन कॉइल is linked with the other coil. Suppose this is what we have primary coil, this has a secondary coil. Let us suppose the number of turns in primary, here we are using the symbol 1 and 2, coil 1, coil 2. Number of turns in coil 1 is N1, number of turns in coil 2 is N2. Self-inductance of coil 1 is L1, self-inductance coil 2 is L2. EMF which is induced in first coil say E1, EMF which is induced in secondary coil say E2, current say I1 and I2. Now this part is very important. What do you mean by this? This is with respect to our coefficient of coupling. So change in magnetic flux in first coil say flux 1, change in magnetic flux in second coil say flux 2. So जितना फ्लक्स यहाँ पे चेंज होगा उसका फ्रैक्शन इसके साथ लिंक रहेगा. Coefficient coupling is a fraction of magnetic flux in one coil that is linked with the other coil. So इसमें suppose flux to अपना flux 2. So flux 2 is equal to we can say k times the flux 1. अगर total flux जितना यहाँ पे change हो गया उतना ही अगर यहाँ पे change हो गया then we can say flux 2 is equal to flux 1. So total flux 2 यहाँ पे जितना change था उतना पूरा इस पे link है then we can say flux 2 is equal to flux 1. अगर fraction of linked flux 1 is linked with 2, then we can say flux 2 is equals to whatever fraction is there, that fraction into flux 1. Same thing here also, the flux 1 in the first coil, अगर दोनों में completely link है then we can say flux 1 equal to flux 2. But अपने को coefficient of coupling देखना, that means fraction. So fraction of flux 2 is linked with the flux 1, that you can indicate by flux 1 is equals to k times the flux 2. I repeat, coupling fraction of magnetic flux. So flux 2, that is flux in secondary coil, let us say fraction of flux 1, and in coil 1 flux 1 is equal to fraction of flux 2. Now by definition, that is formulas, self-inductance of a coil L1 as we did, N1 flux 1 upon I1, secondary coil का N2 flux 2 upon I2. Self-inductance is the EMF induced in the change in magnetic flux in the same coil due to change in current in same coil. That means EMF induced in same coil due to change in current in the same coil. That is our self-inductance. So N1 flux 1 upon I1, secondary के लिए N2 flux 2 upon I2. Mutual inductance M, that is change in current in one coil, EMF induced in second coil. So N2 flux 2 upon I1. If I take first coil, then N1 flux 1 upon I2. See the formula for the same. But flux 2 is equals to K flux 1. So flux 2 is equal to K flux 1. And flux 1 is equals to K flux 2, K flux 2. So M is equals to, we got N2 K flux 1 upon I1 is equal to N1 K flux 2 upon I2. We'll multiply M into M. Means M square is equal to M into M. What is M? M is equals to this as well as this. तो दोनों का वैल्यू यहाँ पे डाल दिया, this into this. Just rearranging K into K, K square. N2 यहाँ पे flux 2 लिया मैंने because multiply कर रहा हूँ, so I can change the order. N2 into flux 2 upon I2 means 2 I wrote one place and 1 I wrote at one place. So N1 flux 1 I1 here, N2 flux 2 I2 here. K into K, K square. This N2 flux 2 I2 is self-inductance of secondary coil. N1 flux 1 I1 is a self-inductance of primary coil, that is first coil. If I take a root, M square is M, K square is K, root of L1 L2. Note, if K is equals to 1, then अगर K अगर 1 है, then we can say the two coils are perfectly coupled. That means if I take k is equals to 1, that means flux 2 is equal to flux 1. मतलब जितना चेंज यहाँ पे फ्लक्स हो रहा है पूरा फ्लक्स यहाँ पे भी सेम चेंज हो रहा है. That means both the coils are perfectly coupled. If k is greater than 0.5, then we can say they are tightly coupled, and k is less than 0.5, we can say they are loosely coupled. Fine. Next part, transformer. First see the meaning. Transformer is a device used for changing the voltage of AC from low value to high value or vice versa. Remember students, at our power station, that means where power generated, we are generating AC voltage because AC voltage is economical as well as cost effective. So whenever AC generated at one place, we have to carry from one place to another place. In that case, we may require to change the voltage, that is AC voltage, low voltage to high voltage, or we may require to change high AC voltage to low AC voltage. That job is always done with the help of transformer. So we can use the transformer as device which converts AC from low value voltage to high value voltage, or we can convert from high value voltage to the low value AC voltage. It based on completely mutual inductance. What it consists of? It consists of this is soft iron core, and on this we are wounding a primary coils and secondary coil. So primary and secondary coils insulated from each other, wound on a soft iron core. This primary coil acts as an input where we are connecting AC source, and this as a secondary act as a output. Diagrammatically we indicate this way. This is a primary coil, this as a secondary coil. AC voltage applied to primary coil, and we are getting output at secondary coil. Now what the concept says, let's see here. When AC voltage is applied to primary coil, when you apply the AC voltage to this primary coil, the current through the coil changes. As a result, magnetic flux through core also changes. Obviously, as per Faraday's law, when a current in primary we apply, as current changes, the magnetic flux linked with this coil changes. This magnetic flux linked with other coil also changes. When the magnetic flux linked with the other coil changes, EMF get induced in the secondary coil. That we did just now, that is mutual inductance. So as I said, transformer is based on mutual inductance concept. So here again, as AC voltage is applied to primary coil, we are applying AC voltage to primary coil. The current through the coil changes, current through this coil changes. The result, magnetic flux through the core also changes. This is core diagrammatically, right? So magnetic flux linked with this core also changes. As this changing magnetic flux is linked with both the coils, this changing magnetic flux linked with both the coils, EMF induced in each coil. मतलब इसमें भी EMF induced होगा और इसमें भी EMF induced होगा. Now let magnetic flux link per turn both the coils at instant is say phi. So formula for secondary coil, formula for primary coil. Let us say number of turns in primary is Np, number of turns in secondary is Ns. Then flux in primary, flux we assumed here magnetic flux link per turn. The magnetic flux link per turn is phi. So number of turns अगर इसके Np है तो इसका magnetic flux कितना होगा? Np into flux phi. इसके number of turns अगर Ns है तो इसका magnetic flux कितना होगा? Secondary magnetic flux is Ns into phi, because flux phi is a magnetic flux link पर टर्न, एक टर्न के लिए इतना है. तो यहाँ पे नंबर ऑफ टर्न NS है तो NS इंटू फाइव, यहाँ पे नंबर ऑफ टर्न NP है तो NP इंटू फाइव. EMF in secondary is d pi by dt as per our formula. Secondary flux we have NS phi, NS will took directly outside, NS d pi by dt. EP in the same manner, EMF induced in primary, d pi by dt, flux P, that is in primary, NP phi, this NP we took outside, d pi by dt. If I divide this upon this, then ES upon EP is equals to, this get cancel, you will get NS upon NP. So EMF in secondary to the EMF in primary is always equals to number of turns in secondary to the number of turns in primary. That means EMF induced in secondary primary is basically linked with the number of turns in primary and secondary. For ideal transformer, input power has to be equal to output power. But what is power formula? E into I. So primary, that is input, EP IP, output, that is secondary, ES IS. So I can say ES upon EP is equal to IP upon IS. We are writing in terms of ES upon EP, ES upon EP, so that we can equate these two. So if I equate 1 and 2, I can say ES upon EP is equal to NS upon NP, that is current EMF and number of turns directly proportional. ES upon EP, NS upon NP. But if you see here, it is ES upon EP is IP upon IS. So ES upon EP is IP upon IS. So EMF is directly the number of turns and inversely proportional to, we can say, current. There are two transformers, step up transformer, step down transformer. Step up means we are converting low value, low voltage, AC low voltage to AC high voltage. So step up transformer. Step down transformer, that means you are converting high AC voltage to low AC voltage. For step up transformer, if I see this equation, step up, that means number of turns in secondary, EMF secondary में ज़्यादा होना चाहिए, तो EMF secondary में कब ज़्यादा होगा? Number of turns in secondary has to be greater than number of turns in primary. EMF in secondary has to be greater than EMF in primary, but current को inversely proportional है. That means current in primary has to be greater than current in secondary. This is condition for step up transformer. Step down transformer, we can say NP is greater than NS, EP is greater than ES, and IS is greater than IP. Thank you, students.